Hello. In this video, we're going to look at rational numbers and specifically how we can convert them between fraction and decimal form. So remember that a rational number is any number that can be expressed as a fraction with an integer numerator and denominator. And so sometimes it's more useful to work with them in fraction form, sometimes in decimal form. So knowing how to convert between the two is very useful. If we're converting a decimal or a fraction into a decimal, then we just need to remember that a fraction is essentially a division. Some of them you will know. So when you see a fraction like 3 out of 4, you will recognize possibly that that is 0.75. Or when you see 2/3, you may recognize that that is 0.6 repeating. But there are others that you won't necessarily recognize. So let's say something like 11/23. If that happens to be a fraction you have memorized, great, but it seems improbable. So what we do in these instances is we actually do a long division. Your format for long division might look a little different than mine. And what we know about this is that eventually, when I do this division for any fraction, I will either get to an end, it will be a terminating decimal, or I will start to see something periodic, it will start to repeat. That could take a long time. It could happen within 2 or 3 digits, or it could take hundreds or even thousands of digits, depending on the fraction. We don't necessarily need to wait to see that repetition or that end, because the precision that we'll need is usually like 2 or 3 decimal places. So I'm going to start here by dividing 110. How many times does 23 go into 110? And that's, not a super obvious one, but if you think about how many times 23 would go into 100, that's 4. So I'm going to go with 4 here. And then I multiply 4 times 23 to figure out what I have left over. So I have 92 there, which means I have 18 as a remainder, which is less than 23. So 4 was good. I don't need to bump it up. I now have 180 divided by 23. So 23 goes into 187 times. And then 7 times 23 gives me 161. Oops. Which is a remainder now of 19. 190 divided by 23, that goes 8 times. Now, these aren't like particularly easy divisions, but they are doable. I am going to go up here and add one more thing because I started putting digits above this first 0. I'm lining up my decimal point here. So what I'm dealing with here is 0.478. So 8 times 23 is 184. What I'm recognizing here, notice that when I divided 180, that 7 times 23 was 161 with a remainder of 19. So I was 4 shy of what I needed. So that actually is a pretty solid hint here that if I do 184 divided by 23, I'm going to get actually a perfect value. So this one does end at 8. Oh, sorry, what did I do? Nope, I did not subtract yet. Oops, ignore me. I got ahead of myself. 6. Bring down another 0. There we go. I knew I was in the wrong decimal place. It didn't seem likely that this would end. I thought this was going to repeat. So 23 goes into 60 just 2 times. So 46, which is 14. I'm going to actually stop right here because I can see that this is going to go on for a little while. But 3 significant digits is a pretty good standard for what we want. So I can say that this fraction is approximately equal to 0.478. If I want the nearest thousandth, then I need to go into the 10,000ths place because I need to go one extra digit to know how to round. So getting to the 8 and stopping isn't enough because if this next digit had been bigger than 5, I'd have to round that up. So I have to go always one more digit than what I actually want. In cases where my numerator is bigger than the denominator, it's still the same idea. Either way, I'm going to divide my numerator by my denominator until I get the right number of decimal places. Going from a decimal to a fraction is a couple different processes, and it depends on if what we're dealing with is a terminating or a periodic decimal. If it's terminating, then I simply need to know how many places I have. So this is the 10ths place, the 100ths place, and the 1000ths place, which means this is simply 3128 out of 1000. That isn't sufficient as an answer. That obviously is the answer, but what I want to know is what is that as a simplified fraction. So I want it dividing out all of the possible common factors. One thing that I can see right off the bat, 28 is divisible by 4, so this numerator must be divisible by 4, and 1,000 is also divisible by 4. So 3128 divided by 4 leaves me with 782. That's not, as it turns out, the highest possible, the greatest common factor, but it is one I noticed right away. There's no point in wasting a lot of my time trying to figure out, and 1,000 divided by 4 is obviously 250. Trying to figure out what the greatest common factor is if I just see a factor. Now I can see that it's still divisible by 2. It isn't divisible by 4 again because 82 is not divisible by 4, but I can divide both of them by 2 again, which leads to a denominator of 125 and a numerator of 391. So now it's not divisible by 2 anymore, but I have to decide, are there any other common factors? 125 is a power I recognize. It's just 5 cubed. So in other words, its only factors are powers of 5, and 5 is not a factor of 391. So that means we are finished at this stage. With a repeating decimal, you may have learned some tricks and tips, and those certainly you may apply in some circumstances. I'm going to show a process here that works for any kind of repeating decimal, whether we have non-repeating digits in front of it or not. So right here, because I have this 3, which isn't part of the repetition, that can cause some problems. Now, you may have learned a strategy, essentially, that if I have like 0.271 repeating, like I have here, that's going to be 271 over 999. So I have a mixed fraction here, which I can then convert into an improper fraction. And that certainly is correct, and it does work. That strategy starts to fall apart when you have things like 0.12 and then just 34 repeating, because only part of the decimal is repeating. So I can't put this on top of 0.9999. There are other rules you may have learned for that, but rather than learning 6 or 7 different rules for dealing with the different situations, I'm going to show you one process that actually explains why that works. Why is this divided by 999? So what I'm going to do is a bit of an algebraic trick, manipulation. I'm going to define this number as x, so 271, repeating. Now what I'm going to do is I'm going to multiply both sides of this so that the decimal now moves to after the first repeat. So in this case, because there are 3 digits in the repeat, I have to multiply it by 1,000. So 1,000x is going to give me 3271.271 repeated. And actually, I'm going to do a little manipulation here. I'm going to actually move this over so that the decimals line up. And the reason I want to do that is because now I have these 2 expressions, these 2 equations that are equivalent. They're just me defining this variable as x and then multiplying it such that I have the period now after the first period, after the first repetition of the digits. Now what I'm going to do is I am going to subtract. So I'm going to subtract the left side from the left side, and I'm going to subtract the right side from the right side. So 1000x minus x is 999x. Because those two are equal to what is on the right, if I subtract what's on the left, that should be equal to if I subtract what's on the right. But if I subtract what's on the right, what's essentially going to happen is all of these repeating decimals are going to go away because I have the exact same digits for every place after the decimal point. So what I'm really subtracting is 3271 minus 3. And 3271 minus 3 is just 3268. Oops, switch back to my blue pen. So 3268. That can then get divided by 999 in order to figure out what x is. Remember, x was the number I was trying to convert into a fraction. So 3268 divided by 999 is what I have. Now I'm going to check for common factors. 999, just as a kind of side note to think about what the common factors would be. This is 9 times 111. 9 is obviously 3 times 3. 3 is not a factor of the numerator, so nothing comes there. 111 is actually 3 times 37. So I would need to check to be absolutely certain, is 3268 divisible by 37? I'm going to tell you right now it is not. So this is the fraction. This is the improper version of what I had here. If I wanted to check that, I could simply take 3 times 999. So 3 times 999 is 2997. And then I add the 271, and I do get 3268 as well. The nice thing about this process is it will work even if I don't have all of my digits repeated. I have to do a slight modification. Same idea, I'm going to define this as x. But my goal is to make everything after the decimal place line up for two separate expressions. So in this case, I can't just use x. I'm actually going to use 100x. So 100x makes this into 12.34 repeating. So in other words, I multiply by whatever it takes to get the decimal right before the first part of the repeating segment. And I'm actually going to multiply it by 10,000, because what that does is gives me 1234.34. So I want to multiply it by whatever puts the decimal right before the periodic part, and then whatever puts the decimal after the first repetition. Now again, I subtract. So in this case, I'm not going to end up with just a bunch of nines, because 10,000 minus 100 is going to not be just 999. It's going to be, 10,000. My brain is not working right now. It is 9,900. 9,900x, and then 1234.34 repeating, minus 12.34 repeating, but the 0.34 repeating parts disappear. So what we are left with is 1234 minus 12, which is 1222. Again, we divide by the 9,900, so x equals 1222 over 9,900. Now this one we clearly can simplify. It is going to end up, both of them are divisible by 2. So when I divide both by 2, I get 6111 in the numerator and 4950 in the denominator. At this stage, I'm going to just tell you right now, these are co-prime. They no longer share any factors. Oh, sorry, I got an extra 1 in there. It's just 611. There are no more factors that are shared between these two terms, so we're good. We're done. The easiest one to check right off the bat is the 4950. I can tell that it's divisible by 10, by 2, and by 5, neither of which is shared with the numerator. The 495 that's left is still divisible by 5, and when I do that, it's 99. So either 3 or 11. 611 is not divisible by 3, and 611 is not divisible by 11, so that must be the finally simplified fraction.